Now, so far we looked at examples where we had just two groups, okay, favorable, unfavorable. Okay, we wanted for just two groups. And the second example was again favorable, unfavorable, but several groups. Okay. Now, what if we have, okay, instead of just having two rows and several columns, but we have several rows and several columns. Okay, so here when we have several rows and several columns, what will happen is the columns will represent one dimension, okay, and the rows will represent another dimension. Okay, like in the examples that we saw, our columns represented different hotels. The different groups, those are different hotels. And the rows represented only whether favorable or unfavorable. But suppose if the rows represent the kind of hotel, whether 1 star, 2 star, 3 star, or 4 star, so it will be the rating of the hotel on the row side. So we have two different dimensions, the hotels and the rating of the hotels. Okay. We want the test that we're going to do, we cannot do a pi sub 1, pi sub 2, pi sub 3 test, because here we have not just two rows but several rows. So the hypothesis that we will test is whether these two dimensions, one dimension represented by the columns, the other dimension represented by the rows, so these two dimensions are independent or not. They have no relationship to each other, or they are somehow related. So we have R rows in the table and C columns. Then we want to see whether the two categorical variables or the two dimensions, categorical variable, the first dimension is one categorical variable, the second dimension is a second categorical variable. Whether these two variables are independent, no relationship at all, that will be your null hypothesis, or they are dependent, that will be the alternative hypothesis. So when you have a situation like this, can we use the same approach, like observed frequencies and expected frequencies, and the chi-square test. So same approach. Observed frequencies comes from the sample, we already have that. Now how do we come up with the expected frequency? That's the only question. Once you know how to figure out the expected frequencies, then you can apply the same approach to find the chi-square statistic and then compare it against the table value. And here for the table value, the degrees of freedom is R minus 1 times C minus 1. You take the number of rows minus 1, take the number of columns minus 1 and multiply that, and that will give us the degrees of freedom. Okay. As long as all the f sub e's are greater than or equal to 5, that is to validate a large sample, we can use the chi-square table to find the critical value and then based on that arrive at a conclusion. So the question is, how do you compute the expected frequencies? Now expected frequencies can be computed using this formula. You take each row, so take the row total. Okay. Don't find the p bar or anything, just row total. Then you have the column total. So row total times the column total. So the row defines a row and a column will define a particular cell, and for that cell, so row total times the column total divided by the grand total, overall sample size. That will give you the expected frequency, and once you have that, then you can apply the formula. And then the decision rule like before, and you'll be able to arrive at a conclusion. So here is an example. We have 200 students, freshmen, sophomore, junior, or senior. So class standing is one dimension. Number of meals per week the student purchases in the dorm. Okay, that's the number of meals purchased is the second dimension, column dimension. Class standing is the row dimension. And here's the observed frequencies. You have taken 200 random sample of students and you have constructed this table. Then you multiply the row total times the column total divided by the grand total, the number of samples. Then you have your expected frequencies. Once you have the expected frequencies, then you can find the chi-square statistic. So row minus 1 times column minus 1 gives you the degrees of freedom, and for alpha of 5% you find the chi-squared table value, And then when you compare that against the chi-squared stat, then here you will not reject the null hypothesis, saying that the type of number of meals purchased is independent of whether the student is junior, freshman, sophomore, junior, or senior. Class standing has nothing to do with the number of meals a student purchases. So now we'll look at an example in Excel.